we can go ahead and get started. I don't think I need to do the spiel again. A couple quick points. Just if you need the email address to ask for a certificate of completion, it's hello@strayos.com. And then keep an eye on your emails in the future for the webinar recording link and for the answers to all of the questions that either are not answered or maybe are slightly awkwardly answered because, we're under, the gun. So without further ado, welcome Ravi Sahu.
Well, thank you everybody for sticking around. I know we have, it's never a morning where you have like a technical difficulties and trying to figure things out, being a tech company, right? So,
at least it's not our tech.
Yeah.
we didn't build this software, so it's okay.
So welcome. We have an amazing presentation today, from Gus from General Drilling. And today's topic is optimized fragmentation using measure while drilling and 3D image analysis. Gus is General Drilling's treasurer and one of the chief drilling supervisor there. He has roughly 30 plus years of experience in this industry, and he's going to be talking a lot more on how measure while drilling can play an important role in optimizing the drilling as well as overall blasting and the downstream process side as well. Today's agenda, we'll cover a little bit just about overview, and we'll look into General Drilling, what their workflows and processes are, and more about their company, and then dive in right into the drilling performance and how you can apply measure while drilling for blasting and fragmentation and what it entails to the safety. And then we also talk about a little bit on the ROI as well, and we'll leave it more time for the Q&A. Hopefully we have a late start here, so if you want to stick around for another 10 minutes, we'd appreciate that. Bit more about Strayos. For those who are our return webinar attendees, you've heard about Strayos, but just to recap here, the company was founded in 2016, and we are present in roughly 8 countries at the moment, and we have roughly teams operating in different regions. That gives us ability to do 24/7 customer support. But our core platform has been built around how this can be applied to day-to-day engineers and the tech services, personnel who are on the site, to use it as a design tool, starting from surveying and blast planning. And then we have a suite of tools built on what we call the AI engine, understanding of the geology, drill and blast planning, and the processing, the fragmentation, and the end reporting. And we have recently launched a suite of new tools, timing, design, loading, as well as the vibration analysis. More on, so what does this create? It creates, since you're using this as a data design tool, it creates a data lake for not only the data capture, but it is bringing all the data in one place, and we can use it to run several types of optimization. And what I call essentially is like a scenario analysis. As you start gathering more data, you can not only build the performance analytics and dashboards in one place, but start to optimize and run simulations, what shot correlated to what type of performance. And if I change certain parameters, would I get an optimized result? And then correlate back to the historical data, but also look forward into your design processes here. And that's what the beauty of keeping things, the design part, as well as the analytics part in one place. So that's a bit more about Strayos. We'll be launching a poll question here, just real quick. Would love to get you guys' thought here. And let me put in the poll here. You can take 30 seconds to answer this poll question. What area do you all work in? And then we'll move back to the presentation. We'll give another 10 seconds or so. It's a good mix of operations folks here, along with the performance side. Nice. So there's a lot of performance improvement audience here. We'll give just one more second and we'll close it. Well, thank you everybody for participating here. And let's move in. And over to you, Gus.
Robbie, you can hear me? Everybody, I assume, can hear me?
Yes.
Off the slide. All right. My name is Jeff Beer. I've been at General Drilling multiple decades. And we're a small company based out of Indiana. We go from all the way up towards Put-in Bay in Ohio, all the way down to Nashville, Tennessee, and Cape Girardeau, Missouri. So we cover a fairly large footprint. We're running almost 30 drills on a full-time basis. And so this is all we've done. We're not blasters, we're just drillers. But it doesn't mean we're not working around explosives and explosive companies, whether the whole gamut of the major players out there. So next slide, please. Let's go back. We're talking about measure while drilling and drill data. And next slide. Why is it important? Go ahead and go to the next slide. Back in the early 80s, our customers and powder people said, hey, we still need to start recording what's going on in the holes. And if you look back what's in the 80s, times have changed between now and then. And if we go forward, one more slide. We created a drill log like this. It was a paper handwritten. We can notice the collar depth, some major geological issues, and some differences in hardness. But it gets going to be very complicated, as well as there's not much room to record on a single sheet of paper or multiple sheets of paper. The next slide. All the data that's needed. And next slide. Paper-based drill logs were never perfect, but they were better than nothing. Relied heavily on the driller paying attention, and the drillers also, if you in particular, can be doing other things while out on the shot. Today we have cell phones. Back then, they could be sharpening bits, they could be raking holes and cuttings, they could be paying attention to the drill and the drilling. With drill logs, it didn't give you a GPS position of the actual drilled holes. It didn't provide the angle and azimuth. Even if you drilled a perfectly vertical hole, there's going to be an angle on it just a little bit because the inclinometer or your bubble is going to be off. And it didn't provide an elevation start or stop of the drill string. It'd tell you, a drill log can tell you how deep you drilled, but it didn't tell you where you started and where you ended, according to geological seams or an elevation. Next slide, please. So the question I've got here is, how are you all doing drill logs now? And this is a full question.
So we have another poll coming in. If you can participate there. It'll be interesting to see how everybody is managing their drill logs. That's very interesting. Still, majority of them are in the paper-based, and some of them are moving on the digital entry side, which is app-based.
Yep, that's typical of what I see currently. But we'll get more into that in the presentation. Let's go back to the presentation there. Thank you very much for that information.
Great. Thank you, everybody.
All right. Now, thanks to new technology, General Drilling got into this, I would call it late in the game, but for what we're one of their early adopters. We got into this about 5 years ago. And this is with a smart drill technology, drones and 3D imaging processing, and blast design software, whether it's in your powder truck or anything. And it all comes together to where you now have something that's quantifiable and measurable and is up to date for the driller, as well as a quarry processing plant, as well as a shooter. And it's all the same information, but we each want different points of it and different parts of it that make it our own data. As a driller, I worry about rock hardness and penetration rate and everything else, but as a quarry processor, you might want to consider ore bodies, how your haul roads go, and everything else. And then as an explosives guy, you might want to worry about how in the world is this blast going to go off. So this data with Strayos, it all comes together in that neat little center circle. And next slide. With better drilling data that you recorded, quality assurance and quality control, drilling operations, this is truly where the best practices need to be. From ISEE and everything, we talk about drill logs and everything else like this. And paper drill logs, they just don't cover everything that needs to be covered. And this is real time and it's good. As a drilling provider, it helps us identify best tooling and equipment that is for that bench and that job that we're on. Blasters, best explosives. Is it really hard rock? Are we getting into a hard rock seam that's brittle and easy to break, or is it soft and punky and more like a sponge? And also helps to improve blast layout. And you can see changes over time in benches as well as in performance. And this is all through measure well drilling. Compare that to a paper drill log, you're not going to get the same information. And it's also non-subjective anymore. On a drill log, it is very subjective, and it varies between driller to driller and time of day and how long he's been working on that shift. So this is very good quantifiable data that is not subjective anymore. Safer blasting processes, that was a difficult word. Fly rock is a big deal, is one of the major reasons why we started to look at this. Is not that we had a huge fly rock problem, but it is a problem. One fly rock incident is a big issue for lots of quarries. So measure well drilling data helps prevent fly rock and also helps you set up safer blast zones. If the driller encountered something that was poor and on a paper drill log, they noted it. Also on this, it's noted all the time, and you don't have to rely on the driller paying attention. Next slide, please.
So we have another poll coming in here. Be interesting to see how what type of drill technology everybody is using on the equipment side here. We'll give it a couple more seconds here. Great. Well, thank you for participating here. So that's interesting information that transition into the next one, which is the drilling performance.
Yes, it looks like pretty much everything was split 50-50, or not 50-50, a third on down the hole hammer, top percussion and all that. But with smart drills and more intelligent drills that can measure drilling performance and measure well drilling data, you also get what is called GPS survey grade. And that's whether you're navigating to the next hole or whether how you're drilling and setting up. And this is so important. The drill with GPS navigation, it knows where it is in the world with centimeter level accuracy. It knows where the hole needs to be drilled, where it was designed to be drilled, and it also records where it was drilled. It knows its desired elevation to be drilled is where it's starting at. So the hole depths are going to vary from hole to hole. And the quarry and blasters need to know an elevation. That's one thing that we found as drillers, that most locations don't know their elevations of where they want to drill. They know that bench needs to be about 50 feet or 20 meters, but they don't know the elevations. And now elevations become really critical. And if you have geological logs of where you're at, those elevations make it to where you can now split the benches closer to a quality seam as opposed to that's where the rock's breaking to. There's no more throwing a tape over the wall or using a burden pole. You get consistent floor control and good quality control. And floor control helps everybody by having better haul roads, diggability. You don't have to worry about toes as much because you're drilling always to the right elevation and not the right depth. Holes are separated accurately for burden and spacing. A centimeter level accuracy, if you're on a 10 by 10 pattern and you're off 1 foot, that's 10%, or excuse me. And if you're off a 20 by 20 pattern and you're off 1 foot, I believe it's 5%. And that's a huge difference in quality on what you're going to get on the dispersal of your explosives in the hole. So GPS navigation and H&S, as well as measure well drilling, all goes hand in hand, and it makes for a much more uniform quality shot. Measure well drilling data. This is a complicated slide, but it's really simple. With GPS and measure well drilling data, you record the color of the hole, and you also you can record whether or not the driller hit mud, water, and voids, all on a touchpad in the drill rig. It also records every second the penetration rate, feed rate, time to drill the hole, percussion pressure, feed pressure, rotation pressure. And depending upon the manufacturer of the drill and what you have wanting to be recorded, it records this on a per second basis, and it is really accurate. A driller can't pay attention that well all the time to what he's doing, as well as recording what's going on the drill. So measure well drilling becomes very precise for what we're looking at. Hole placement accuracy. You can also see how when you compare measure well drilling data to planned versus drilled, hole placement versus drilled, and the accuracy of it is also, you can do what is turned on as bottom of hole navigation. If the driller cannot set up on the hole that is as it's designed, you can now set the drill to where it will drill to the bottom of the hole as it was designed, as opposed to it just drills the same distance away. So it's a really important with this information, and it processes all this information very well. And one of the reasons General Drilling likes Strayos a lot is because they put this information in something that was very easily visualized and worked through. Major drill manufacturers don't necessarily have this kind of software that is readily easily used, and that's why we like Strayos and reached out to Strayos. Next slide, please. Detailed performance allows us to share the best practices between drillers, and it really does. Our drillers are no longer having to focus on making sure the shot report's accurate on an instant-by-instant basis, and they're paying more attention to just how the drilling is going and able to adjust the parameters that they need with the knowledge that the drill is recording what needs to be done. Training new drillers, we can focus on actual operation of the equipment, not necessarily how to fill out the drill log as well. And improve over time, they can see how their penetration rates and their productivity improves over time and how long they actually drilled. It's all quantifiable and not subjective anymore. Different tooling. As your tooling wears out or it needs to be resharpened or wears down, measure well drilling will tell you, hey, my penetration rate's slowing down, and this is the reason why. It also will tell you in a very measurable way what is the best suited tooling that you need. Do you need a carbide button bit? Do you need drag bits? Do you need a ballistic bit? Do you need round buttons? And it helps to really narrow down the best productivity for that area that you're drilling in. Downtime, it helps prevent downtime. You see the productivity of that drill dropping off, it's quantifiable, it's recorded. And you also can measure the performance of new and different changes you make to whether or not you use carbide buttons or if you use ballistic or items like that. And it allows you to measure and actually quantify it a lot better.
So we have one more poll here as really the applications of the data itself, and so it would be interesting to see the responses here. So we just launched another poll. How are you using your current drill data in most of your shots? Interesting. We'll give a few more seconds. Nice. So nice spread out between the compliance and the adjusting of loading and timing. So we'll close the poll. Thank you, everybody. We'll resume the presentation here. So there's kind of, it's a nice segue to really now dive into the optimization side of how the data can help here.
Yeah, let's go back to that the slide before that real quick, Robbie. By looking at just a real quick calculation, it seemed like 40 to 50% of the people are only using it for quality control and quality assurance, or not using it at all. I know in the states that I've operated in, drill logs are required by law, and that's mainly just for safety purposes. But there's a lot of information that mine operators and quarry operators are missing with what measure well drilling data is actually recording and how it works for you all. I mean, it's a big deal. So let's go ahead and go on to the next two slides. With being able to 3D profile with a visual picture through drones, we can build a better plan that actually records the actual burdens where we're at. You can plan that information. You can also see your burdens and where you're at. You can download precise drill plans into your drill. You can actually record where it was planned versus not where it was planned, but where it was actually drilled. You can review in 3D the actual drilled shot with minimum and maximum burdens. That's part of the quality control, but also it records more of the analytics that we're going to get to later that measure well drilling data is going to give you. And you got to remember, this is the start of your quarrying process or your mining process, and it really dictates a lot of things past here. And it's better to pay attention to it from the start as opposed to deal with it deal with it with the start as opposed to deal with it when it ends up at your crusher. So let's go on to the next slide. All right. And this is basically, we're talking about how we lay off a shot, and it pretty much self-populates basically upon an area and gives you your burden. You put in your burden, optimized burden, and it adjusts the holes for you, and it also adjusts everything. And it's really simple, and it's a really good way to go, and to give you an idea of where it goes and how it moves. As you see, those holes are moving to optimize your burden, and you can't see it now, but it does allow you to keep the back row straight. This fully automates your shot layout, and it also allows you to interpret your true geology with measure well drilling. You start off with your digital drill plan off to your left, and once you create your drill plan either through USB stick or through Wi-Fi or Bluetooth, you can transfer that into the drill. And from after you transfer it into the drill takes that data and it converts it into a shot plan that you actually drill. And with the automated drill hole, it tells you where the hole was planned, which is the green dots, versus the red X's where it actually was drilled. And how does that affect your performance? It allows you to see, well, right off the bat, that I designed it here, but we were actually drilled it here. Why was there a problem? What's the issue? Why didn't we get it as designed? And there are many reasons why the hole wasn't drilled where it was at, but why is the biggest question. And it allows you to quantitatively look at what went wrong and what went right when you go back and look at the performance of your muck pile. And now you got hole profile reports with drill logs. And that's the farthest over to your right. And it tells you from different things that you're looking at, whether it's penetration rate, feed rate, rotation speed, percussion pressure, depending upon the type of drill and what things you can record on it. And it allows you to look at that as well as look at your true burden that you have in between holes. It's truly good there. Next slide, please. Also, automate rock strata quantifications and drill log visualizations. Here you can actually see the color-coded drill log as well as look at it through the face and, oh, I've got a soft spot here and I got a cave there. Or you can see everything that needs to be done. or what is happening in the hole, as well as what's happening with the geology behind it. And for us as a driller, that is extremely important, and it makes it a safer shot to be able to plan your shot with. After it's drilled, you can actually see on the face where you've got issues, as well as where you have a difference in the drilling conditions, as well as also the little hole number 1 off to the side. You've got where the hole was drilled versus where it was designed to be, and we're off a 1/4 foot. And that's a big deal as you start to look at things like that. Next slide. And this is another one that is truly a game changer in my mind. You can take the data from multiple shots that you've had over the past, and according to penetration rate, you can see how the fragmentation was. And then after that, you can look at the bottom side, and if you make certain changes on your shots in the future, how is that going to affect your fragmentation as well? And this is all based on measure while drilling data and predictive intelligence. And it starts by taking previous performance and projecting it out in the future. And so if you can make changes, you can say, this is predictive on what if I spread my pattern out, or if I change certain things, my timing or anything like that. And it truly helps you get a better fragmentation, or at least a predictive idea. If I do this, my fragmentation will change. And it allows people to more dial in their drilling and blasting program. It's really big in my mind. Ravi, any questions on that one?
No, I think you covered pretty much it, just I think we will get more questions here. But one thing that I am always curious from the drilling side here is a lot of the times we see how the individual drilling logs, have an effect on the shot performance side, and we see that each shot can be quantified more precisely now with the drill data, and you can start tracking KPIs. Not only 1 or 2 KPIs, but multiple KPIs here is, if you're really trying to reduce your powder factor or cost per overall ton here, this lets you kind of, be a forward thinking process here. And that's what I think, as you mentioned, how your previous shots can play into that role here. And one of my questions for you here in this one, as you see here, what optimizations I think you kind of see other types of drill parameters. We have seen here penetration rate, but percussion, feed pressure, and other parameters you have seen impacting similarly.
It really depends on the location and what you're looking for. Sometimes it's a mud or a water seam or a shale seam that comes in and out, or even a different hardness and the thickness. And it's not always just penetration rate. It could be in rotation pressure, your feed pressure, or even your flushing pressures. I mean, you can see differences in there, which tell you that changes are happening in your geology. And as you get predictive, it tells you this is what I need to do differently to help you get a better picture on how to optimize. And as I said, this is not subjective anymore. This is now quantifiable data that you can go back on and measure. And we're not relying on the loader operator to say, yeah, that was easy to dig. Oh, that was harder to dig. This is now quantifiable, measurable data that is reproducible. All right. Safety. I've alluded to this. Next slide. This does help you with safety. This is just an example. If you look off to the left, hole drill location versus plant hole location. As a driller, there's times that we have to move a hole that we cannot keep it open, or there's an obstacle in the way, or there's a giant crack that is there that we just shouldn't start drilling in a crack. So we have to move the hole, okay? And as fly rock comes from either the face or the top of the hole, if you have to move a hole, you're now, one, changing your burdens, and as well as you're moving energy closer to another hole. So what we're trying to do is eliminate that, or at least be able to record why we did that and see what happens with this. Next slide, please. And this is just an example. If red's the fastest penetration rate and you're on a 4.5-inch hole, and all of a sudden you see that your burden at the bottom, middle bottom, is lighter and your penetration went up, are you going to change how you load that hole? And that's where the safety is. Could we have a blowout at this point in time? Would you change or you stem around that area that is what I consider light burden and high penetration rate? Is that something that would change people's behavior as well as safety factor? And that's just a question that each person in Blaster is going to have to be able to decide. Right there, yes. Is going to have to be able to decide, is this something that I need to be concerned with? With old style drill logs, being able to compare a change in penetration rate as well as a change in burden on the same screen in the same area is not practical. Now with this technology, you can now do both and compare it. And that's where I'm saying this is really going to change how people load shots. It's the way to go in my mind. And this is just from a driller. Continual improvement process. This is really important. Time to drill the shot is based upon footage and bench prior experience. And now we record it and store it digitally. And it's no longer that the driller was down for a half hour. It was he's waiting for fuel is why it took me longer to drill a shot. I know why it took me longer to drill a shot. I see his actual penetration rate. Did he get stuck in the hole? What happened there? So pre-drilling routines, you can constantly improve how much time is going to take to the drill this bench. Bit life expectations. You'll be able to actually record how long my bits are actually footage. Am I having to regrind and everything else with our bits? And the pre-drilling improvements on this is a big deal. Driller experiences and prior measure while drilling for previous shots. You now can say, well, this shot took a little bit longer or less based upon prior drill logs. Now it's actually quantifiable and measurable. And can I see over time it's taking me more time or less time to drill the shot based upon the actual drill data? Why is that? What changed? And post-blast optimization, able to confirm hole placement to as designed. That is a big deal. It does change with your hole placement, how the shot goes off. And if you can actually confirm that we drilled it as designed, or no, we didn't really actually hit the holes that needed to be hit where they needed to be on target. And that's a big way to be able to say what the problems were pre and post blast. And it will affect whether or not, as it changes in your powder factor, your timing, your explosive type, because you now have it recorded pre and post, and it's there. And it is, as I said, it's no longer subjective. And able to recreate shots for better failure or even success analysis. If you have the drone pictures before and the 3D imaging, the 3D design before and post shot, it makes things so much easier to create what went right and what went wrong. And it allows you to keep moving forward as opposed to, I think we need to do this differently next time. Next. Plausible deniability. This is one of the things that we at least run up to as drillers. With an old style paper handwritten drill log, there's plausible deniability that the driller didn't note it or record it on the drill log, or the geology wasn't there, or we didn't see that. With measure while drilling data, it's recording all the time what's going on in the hole. And as blasters and people that are in charge of shots, is this information worth acting upon? Because now it no longer becomes subjective, or was it left off, or we didn't see it. It's recorded now. And plausible deniability on what went wrong is less and less towards the driller. And as a blaster, that is something that is concerning to them. And that's one of the things that if the information is presented to a blaster or a quarry superintendent that they have an issue or something that has changed in their shot, Do they have to load around it differently? And what is the consequences if they do or don't? Now you have this data. Are you acting upon it? And that makes it a little more difficult. And that's just one of the things that I've experienced in the past, is that I don't know if I trust this information, or if I do trust this information, what do I do and how do I handle it differently? It's changed. And it's changed from where we have been and where we're going. So, does it generate return on investment? Less fire lock and safer bench, I can say that's a definite yes. Being able to drill to the right elevation, as well as making sure everything's done, absolutely. Your haul roads and everything else, and your bench control and your grade control becomes much better. Better rock characterization, absolutely. We have some of our customers that this is the only drill that they want because of that. They can tell when they have a change in their geology that they need to change how they mine and shoot based upon qualitative measures in the rock. They're not just looking for, they're looking for chemical analysis on the rock, and they can see that and be able to record where it happens based upon penetration rate and feed pressures. Consistent diggability and measurable burdens, yes, absolutely, huge. It is very consistent. I mean, centimeter level accuracy on this, and that's a lot better. Well, we used to tell our drillers, you're within a foot or two, you're good. Not anymore. This brings it right down to centimeter level accuracy. And it allows also for changes, quantifiable changes, to be measured for evaluation. And that's a really big deal. We no longer have something that says, hey, this shot went really well. Why did it go well? Well, we can find out why. It's no longer just in a paper drill log. Quantitative, these from reduction of powder factors and crusher throughput and reduced fines. This is through a couple of studies from Robbie. This is a big deal in my mind. You want to talk a little more on the quantitative side, Robbie?
Yes. So this is some industry numbers that we have seen how the measure while drilling and combination of the customized, loading. So customizing your density has resulted into the improvements overall in the quarry side, roughly up to 35% reduction in powder factor. And this is a period of kind of, studies where the drilling companies as well as the blasting companies are collaborating together to roll out the measure while drilling as well as the customized loading density differential energy loading programs here. And so these numbers speak for itself, and these are some big numbers which has seen not just on the quarry side, but also if you see on the mine side how just few percent increase in the shovel productivity can lead you to a lot of profitable operations here overall. And we'll be happy to kind of provide more information on how this case studies kind of has been carried out as well. So, but this kind of brings the end to the presentation here. I hope that was useful. We'll dive into the Q&A, because one of the things that Gus mentioned is presentation is great, but I think we can really spend more time on the Q&A here. That's where a lot of the interactions and per se kind of enlightenment happens, not just for us as a presenter, but also for we as a presenter kind of understand the questions and get enlightened here. So feel free to dive into your Q&As. We'll monitor the Q&A options here. I see a bunch of them to start with. And I will be moderating these questions based on the votes that we have received. So let's start with the first question here. What MWD categorizes do you select to identify geological characteristics such as broken material at top, cracks, seams, void that could influence loading? Is it possible to identify hole wander? Gus, do you want to take that up?
Hole wander. There's two types in my mind. There's two types of hole wandering or deviation. One is truly just a setup, and with GPS and HNS hole nav you're going to record right off the bat whether or not it was on target with its angle and azimuth. That's the first type of hole wander. The second one is based upon geology and hole color. And hole color, being able to deviate, to generate deviation-based reports on measure while drilling data. If you consistently hit a bad seam everywhere and your drill string kicks off, and the only way to measure whether or not you're deviating down the hole is to actually measure it with a bore track system and how much it is. That's the biggest thing for geology-wise. You cannot actually measure it, but you can see a tendency over time. Oh, the penetration changed drastically in this point, and that's a point of time where I have a difference in your geology as well as deviation. Hole collaring, if you can't start the hole straight, you're not going to have a straight hole, is generally what I tell everybody. That does depend on the stiffness or the outside diameter of your drill string, but that is something that takes time to look at. And anytime if you hit a seam that is down below where you're at, and you might see a difference in your rotation pressure or your feed pressure for your deviation, you won't be able to record or actually determine which direction it decided to kick off in, because it's going to follow the path of least resistance. So measuring deviation down the hole, it can give you an indication of where it is, of where it's happening, but it can't give you an indication of what direction that's going. Hope that answered the question.
Great, thank you, Gus. Another question we have, the most votes here, how do you take block model information into account as well as while designing the drill pattern? So I can answer that. So if you have the block model data right now, we accept that as a DXF. If that's you have in that file format, the actual other geological block modules that on the 3D surfaces side, that's something that's in our roadmap to implement there. Few other questions here. How do you keep drill chipping out of the hole after drilling? So more for you guys, this one.
How do I say that? I asked the question. I'm trying to see. How do we keep the cuttings coming out of the hole after drilling? I think that is what it's asking. You have to either have a cyclone off to the side or move the cuttings off to the side. I see a lot of people in big mines that keep the mast up and move from hole to hole. And if you're not moving that curtain, you're raking cuttings back in. And that's it does not make for good results in the bottom of the hole. So I think that's what you're asking. You have to move the cuttings away or the chips away from the hole before you actually move from that next hole.
Mm-hmm. Okay. Well, we have a bunch of more questions, so we'll continue diving into those. So one of the questions here is more of a statement as well as question. So this is all great for mine or Corey, where you can develop AI and data over time to plan the next blast better. But could you talk now or in future talk about what can be done on a smaller project going into a new or unknown geology, where the length of the time of overall project would be not as long? I've seen some answer like rock hardness slide you showed. So I think the overall summary of the question here is, what if the project duration is very short, like, more of a, you shoot it, typical construction blasting types of project where you have a limited, duration, it's not longer. How do we take into the account where you have limited data to play in to optimize the future shots? I can answer part of it, but I think Gus, you can also chip in here. The way I see it is if you have a shorter project duration, but the measure while drilling data, the the information itself becomes useful as soon as you start collecting, right? It's giving you the rock characterization and everything. So even though it may not can be applied immediately for the prediction side, how your future shots can be optimized, but you can still start to apply on as that specific project itself, right? So you may be adjusting may not be adjusting the overall design parameters, but you can still apply to control, few outcomes. In this case, loading side as well as the safety side can definitely be optimized for the very specific data that has been collected for one project itself. But because do you have any experience on the shorter project duration where the data is only collected for only a couple of projects?
Not much. The only time that we have that issue or these issues is when we start into greenfield sites in mines and quarries, or a new area of a mine that is completely greenfield or new. So that becomes a little more. Doing this using measure while drilling data for a road cut or construction site, I think would be important to at least know what's going on the ground. Whether you've got mud seams, mud cutters, and changing your geology from hardness of from granites to anything else. I think that's important to notice where that happens and at least stem around. If you're in construction sites, caution is by far the biggest concern. You don't want to shake the neighbors, and you don't want to put fly rock where it's not supposed to be. So caution is the biggest thing, and that's where measure while drilling data will help you be more cautious in areas that are new and unknown at that point in time. I hope that answered your question.
Yeah, thank you. We have time for a few more questions here, so we'll continue. One of the questions that I think it's very interesting here is, do you measure the real path of each borehole, or only the collar and the end? So I think in the context is, does the smart drills measure each interval, or only the collar at the and the end?
Okay, that is a good question. For the beginning azimuth and direction of beginning azimuth and angle of the hole, the drill only measures it, I think, for the first 3 feet or first meter. Then after that, it no longer records the azimuth and angle. It just calculates and says that that's how the rest of the hole is going to go. So that is done at the beginning of the hole, at the collar. And the rest of the measure while drilling data is recorded as it is drilling. Your penetration rate, your feed rate, your flushing pressures, that's all recorded as you're drilling. But the beginning azimuth and angle is only recorded at the beginning.
Yeah, and this is the cases where you can supplement the bore track data along with the measure while drilling data to be more precise if you want to track your borehole path.
Yes, bore track is a necessary instrument to for us. We use it for quality control to make sure when our angles are on K, that our drillers are setting up correctly, and that's a necessary just a back check, as well as on holes that are concerning, bore track it. It's that simple.
Great. One more question here. MWD provides data while drilling. What if a machine, drill bit, or rock tools are wrongly selected? How to judge the suitability of machine itself prior to drilling? What are the factors that needs to be considered?
Lots of factors. It all depends on, one is what's your end product, what's your fragmentation, what's your diggability that you want, how tall is your bench, what kind of material are you going to be drilling through. Drill tools, if you have a wrongly selected tool, it's going to work wrongly. If the only tool you've got is a hammer, then everything's a nail. So you need to be able to make sure that you have the right tooling available and the right machine setup. A rotary drill is not the same as a down the hole. machine. Yes, they're comparable, and you can use one in exchange for the other for a little bit, but the right tooling setup makes a lot of difference. Not tooling, but the equipment setup. A hydraulic drill is not going to drill a 10-inch hole.
Okay, great. Thank you. Another question here is, how does measure while drilling data considers lithology? Is it through penetration rate values? If so, then can it also indicate which rock it is?
Yes, no. Yes, it does through lithology. We've had some people that are looking for, there's a difference in penetration rate depending upon the chemical quality of the rock. And that's one of the places that we use this at, is to actually determine, oh, the chemical quality of the rock changed at this point in time because the penetration rate picked up or dropped off significantly. So that is, while they're loading the shot, is based upon the measure while drilling data and the penetration rate. Lithology, you can also be measured if you're looking at flushing pressure, or if you're looking at rotation, or even feed pressure. It all depends on, you need to find the factor that works, or the factors that work best for you and your geology of what you're trying to accomplish. Can it determine lithology? Yes. We were looking for a seam that was about 2 centimeters in thick, that we were looking for to be able to split a bench at for quality. And that seam came in and out, and that was extremely difficult for us to be able to hit and target on a consistent basis because the seam dropped in and out. But you can see it at times, and it does help. If it is a very pronounced seam that is consistent, you can see the difference in lithology. But you have to be looking for it, and you have to say, okay, this is what I'm looking for, and it happens at around this area.
Awesome. No, great. Just to add more on to that, like, can you determine the lithology? I think this, or characterize more rock better. One of the things that where the data plays an important role is if you have, with the consistent penetration rate for that specific site, the model, the AI model, can calibrate to your specific geology and start to kind of build this indicator of what type of rock it could be for your data that you are getting, you're collecting through your machines. So that's the answer is, yes, which kind of Gus said. But again, going back to the data here, we have time for just one more question since we started late. So I'll let kind of one more, and then we'll wrap it up. One more last question here is, what, if anything, are you looking to add to this technology? For example, geophysics, or maybe a place where we could share data. So I'll just answer this. Yeah, so the way the platform is designed, it can accept data from anywhere. So any type of file formats. So geophysics data, any type of other downstream data, so like crusher data, as long as you have data from other types of equipments, all can be combined and mined and processed and generate insights from it. And the sharing of data, since it's both offered as offline and the cloud, you have the data shareability also built in. So that I hope that answers this question.
I do have a little bit more to add to that. As I said at the beginning of this presentation, hopefully it was clear that as drillers, I have certain information that I want to share and provide, and there's other information that the mine operator wants us to share and provide, as well as the blaster. And we all have different concerns and needs and different data that we look at. And that's one thing that's nice about Strayos with a cloud platform. It's all shareable. It's all there, and you can make sure that the blaster gets what they need, the driller gets what they need, as well as the mine operator. It's really, we all have different informations and different needs, and it makes it very easy to get what you need and get what you want.
Awesome. Well, we're almost on, little over time here, but Thank you, Gus, for the presentation today. This was very insightful kind of for me, considering like, what are the use cases out there and how you've been applying the measure while drilling data in your operations. And I want to thank everybody in the audience here for taking the time to join here. Feel free to reach out if you have any more questions. If you want to learn more about the measure while drilling use cases, give us a shout. Just a little housekeeping. Gus can be reached out as gus.dyer@generaldrilling.com. We'll put that in our email reach out that we will do if you have more specific questions for Gus, or you can also reach out to us if you would like to have any other further questions. Until then, until next webinar, thank you, everybody. Have a great rest of the day, and have a great rest of the week as well.
Thank you all, and
Bye.
sorry for the technical difficulties in the beginning. My fault. Thank you.
Oh, good. Thank you, everybody.
Thank you.
Bye.